All right, so it's time for the migrating C++ builder code to 64-bit. I have with me in the studio, I have Bruneau Babet. Hello, Bruno.
Hello.
I have JT.
Good morning, everyone.
Director of Product Management. And I have Lee Canty.
Hi there.
The goal of these series of meetings with R&D members of the C++ team here is to have a conversation. And I certainly have some questions that we'll be asking to prompt the conversation, but we welcome anybody on the call to enter questions anytime, and we'll try to bring those in as we go along. So a little more live kind of feel with the conversation. But first of all, I'd like to welcome you guys to the CodeRage sessions.
Thank you.
And these are a series of sessions. We'll be doing this one over the next 45 minutes, and we'll be talking to Lee and to Eli as well, separately, with separate topics around the noontime hour here in California. Again, conversations about the new toolchain and getting into some technical bits about what we did to deliver this toolchain. So first of all, I'd like to congratulate you guys and the team on delivering this product. Our C++ builder developers have been looking forward to a 64-bit compiler for a while, and I think even more importantly is that this new architecture sets a foundation for our future offerings. And it's very exciting to have high levels of language compliance, continue to support our libraries, VCL and FireMonkey, and to see a future where we can get onto mobile platforms as well. Bruno, why don't we start a little bit with just you telling us a little bit about yourself. I mean, you and I know each other from a long time ago, having worked on various products and technologies at Borland many years ago. So tell us a little bit about your history with these technologies and a little bit about yourself.
I started at Borland in 1989. Turbo C++ 1.0 had just shipped. I was in tech support. If I'm not mistaken, Lee was also in tech support at that point, although he had just moved or was just about to move. I don't recall exactly.
I was a user of that product.
Yeah, I was actually a user of Turbo C 2.0 too. I was working on Intuit and had bought the compiler and had learned how to write code in C++ at that point. And then later, back in those days, we used to do projects for R&D back in tech support, things that were could not make a particular release. So I did a couple of projects for the R&D team, message crackers in the debugger, and then I worked on Make for a little while. And then in 1992, I joined the Object Windows team, initially to work on a product that didn't ship, was Alpha Appware. It was basically taking the Object Windows library on top of this cross-platform framework from Novell. And then when Alpha Appware went to Vaporware, I came back and worked on C++ Builder, first as components, and then later ActiveX, and then various frameworks, and slowly kind of became more involved with the compiler. And very recently, about 2 or 3 years ago, kind of started focusing on the compiler itself. But most folks on the team have overlapping responsibilities, so we all do a little bit of everything. So you touch a little bit of runtime, you touch a little bit on the Delphi side, and the Delphi folks come and do a little bit on the C++ side. So I like the way we get to do a little bit of everything. So.
Good, thank you. Well, so this release is built around a new architecture. Why don't you tell us a little bit about it, and how does it compare to BCC 32, the previous architecture that we had been working with for many years?
Maybe I want to bring something up because I can show that a little better. But
sure.
The word that you'll hear a lot is Clang. Clang is the new compiler, and I'm trying to put in the slides as much information as possible because I know we cannot cover all the things that we want to talk about in the time here. So it's based on this new compiler, modern. I'm quoting a few things from the website, but I give you the link to the actual website. So the way they describe it is a modular library-based architecture, real-world production quality compiler, conformance with C++ and C and Objective-C, and I've put there also a few talks from either the LLVM conference or from actually Channel 9 on MSDN, where people have talked about Clang itself. So this is the basis of the compiler that we use for 64-bit support. And in the back end, there's LLVM. I mean, I don't need to say much. Again, I put the link there. Probably the two things that come across is like, LLVM targets multiple architectures or CPUs, and then has great optimizations. There's also an online demo where you can actually type in C code and just see you can see either the x86 or the x64 or the IR generated, and it's actually very interesting because you can type your little hello world and say, and see the code. And the code looks pretty cool.
That does sound fun.
So I've put the links there so that people can play with those.
So you bring up LLVM. Many of the people on this session may not be familiar with it. It is a open source project that was started partly by Apple, right? I mean, the Clang part of it, at least. So there's many big companies that are actively supporting and working on this project.
Oh, yeah. There are several products or companies behind it. Going to the LLVM conference, which we've been doing, one gets to hear about various products or various companies that are working with either LLVM or Clang and LLVM. We get to run into other compiler folks, friends of ours that have worked together that are now working at other companies that are also working with Clang.
The Borland network definitely is out there.
Yeah.
And one of the things I thought was kind of interesting with LLVM is it doesn't need to just target CPUs. I know NVIDIA is working on a GPU generator, so you can run basic any kind of application code on their GPU.
Yeah, there are lots of things that we're not even touching. I mean, in that world of LLVM and jitting and interpreting, compiler C interpreter. There's then one out there called Clang. I mean, there are different things that LLVM can do, and definitely target all those different CPUs and the optimizations. When one of the members of the team here recently just sent a list of the optimizations, I was like, whoa, it's just a huge list of optimization there. I give the link there to the passes, they call them. So.
So that's a huge benefit, to, as open source, as we all know, one of the benefits is that there's a lot of people working on it, and on a back end in particular, companies who make CPUs or what some people call it the silicon care a lot about that code running as optimally as they can on their platform. So you got a lot of people really focusing on back end optimizations, I imagine.
Yeah,
that's going to be a huge benefit.
It is.
So in what other ways would you compare it to the BCC32? Let's talk about the standard language, for example.
Oh, well, I mean, Clang is compliant with the C++ standard. BCC just, had been architected in a way that it's not BCC's fault. It's just the way it had been architected at the time. C++ didn't even exist, and then as C++ came along, the support was added. But template really is the area that pushed BCC really, to the limit, because it was just at the time things were written. I mean, you think back in those days, things were written to use a lot of global variables, no context, and just speed was really the goal there. Just parse it really fast, and if you could parse it, that was great. But when newer things came along, you really need a more modular, more modern compiler. And so BCC had pretty much reached its limits with templates. I think I've posted over and over on the forum that there were several limitations we were running into, especially when you had like nested templates or templates of templates, and we just couldn't do things correctly because the architecture just didn't allow for it. And also there were some more fundamental things, like the way memory allocation is done. I mean, it's just the compiler would run out of memory, but really what it meant is it ran out of a local heap that it allocated up front, and that wasn't really easy to change because it wanted a huge chunk of memory that was all contiguous and committed, and you had to make a choice up front how much that would be, and then if you gauged too little, well, you ran out of memory. You gauge too much, maybe the machine could not support that, especially when running inside of the IDE, where we have precious space because the IDE is also fragmenting memory a little bit. And so there were lots of architectural issues with BCC. I mean, it's a great compiler. It's fast. And for code that it handles it very well.
And when you say it's fast, you're referring to compile time in particular, right?
Yes. Yeah.
Now, and is a large part of that because the way that we work with the front end and the back end and passing the parse tree back as opposed to using an IR?
Yeah, okay, yeah. Now you're getting into the nitty-gritty.
We might want to say that for Eli, huh?
Well, yeah, BCC doesn't have the same level of, like, Clang is clearly, basically there's a parse phase, and then you have an AST tree, there's a semantic analysis, and then that tree is handed to the back end. BCC didn't do things like that. BCC just actually, not even at a function level, at a block level, each block would be, a tree would be made, and then that little block, think like a while loop or for loop or an if or something like that, that little chunk of code would be handed to the backend right away, and the backend would code gen, and then when it came back, that was forgotten. I mean, like, so you can imagine the kind of things that are very limiting when you do it that way. Like you couldn't optimize a whole function,
right,
for example, because each block was code gen on its own, so you couldn't realize that, for example, you could reuse a piece of stack that had been used in each block. I mean, there were things like that that couldn't be done. And much less if you wanted to do it at a translation unit level, you wanted to get the whole AST to understand, let's say, find references, or, I mean, things were very difficult. Optimizations across function calls, no. So, yeah.
So this certainly gives you a lot more flexibility moving forward.
Yeah, but that's just one of the areas that it gives us more flexibility, but overall, just Clang is much better architected.
And speaking of that flexibility, in order for us to deliver a 64-bit compiler that has value to our audience, means that we need to make it work with VCL and FireMonkey and understand Delphi isms.
Yes.
That's probably an area you spent a lot of time on, I imagine.
Yeah, so I have a little slide here that I described. So basically, this goes to what we needed to do. So I'll refer to it as BCC64. So the first thing we did is we added a switch, -F boolean extensions, which is basically where our extensions will come in. The extensions that we needed to add were actually in two groups, Windows extensions and then what I'll call Embarcadero or Delphi extensions. Those are the things that BCC32 already supported that were there to interrupt with the Delphi language, like, class ID, class method, closure, property, published, and so forth. But before we even got to that, we had to do the Windows extensions. Clang is not necessarily very far along as far as Windows is concerned. I mean, Clang is used mostly on other platforms such as OS X and Linux. So some of the Windows extensions we had to do is UUID of, or some of the decal spec, DLL export, DLL import, select any. So those are the things that we focused on. So we did those at the front end, and if you recall, we use Clang to do audits in XE2.
That's right, yeah. So this isn't our first time shipping Clang.
Correct. So the first pass, we had to get all those front-end extensions handled by the compiler. In some cases, the compiler just ignored them. Like for auditing, we didn't really care, about certain things, like whether the UUID of really, had a GUID to back it up or not. So it doesn't matter. The front end would just eat it and say, okay, fine. But now we do, because now we're going to generate code that either has a GUID or has to give you an error that says, hey, this particular class or struct or interface doesn't have a GUID attached to it. So that's the basic of the extensions. It's kind of simplifying it a little bit here, because there's way more that goes on, especially for exception handling and debugging. So I'm focusing mostly on the front end because that's where I spend most of my time. I'll let Lee and Eli talk about, there's a little more that happens, a lot more that happens on the back end, like PData generation and debug info, because there's more that we did to Clang. But my view of Clang is basically take Clang and add these Windows and Delphi extensions. That's my primary focus.
Right.
So. And to answer your question, that's what it takes to actually interact with VCL and FireMonkey, although you need the backend also. You need the generation.
So there's a language part of it, but there's also a library part of that too.
Yes, there's a library part of that we refer to here internally as emuvcl. It's a misnomer, but it's basically a C++ library that emulates types that are built-in types in Delphi. So string is a built-in type in Delphi, TD, time, currency, and so forth, variants. So we emulate those types with a library, but to be ABI compatible with that library, we also have to make some compiler magic. So those types have little decal specs on them, maybe like decal spec Delphi return, or they have a little something somewhere that says, you know, I'm passed this way or I'm returned this way. There's a little bit of magic in the compiler. It looks at the classes and it determines based on whether it has a trivial constructor or a copy constructor or destructor what it needs to do. Some of those types are ref counted, for example, dynamic array and strings. So there's a little bit magic. So that's the part that is part library and part compiler. And so that way, when you're passing a string or receiving a string or sending a dynamic array to Delphi, the C++ compiler sends that information or reads the information back in a way that's ABI compliant with Delphi and not necessarily with regular C++ ABIs.
Right. And ABIs are useful when you're trying to link in static libraries, but there's more to it than just that, right? There's obviously format, many other issues.
Oh, yeah.
So in general, trying to, I think, have compilers work across binary compatibility is a tremendous amount of work with not necessarily a lot of benefit.
Yeah, in this case, I should point out that Clang follows the Itanium ABI, which it made it easier for us because there was already a standard to follow. So what we did in this release, x83,
which doesn't exist on x86-32, right?
Yeah, correct. But Delphi 64 now follows the Itanium ABI to a certain extent. I mean, like the mangling is Itanium ABI. We've certain extensions that we've done, we've added, but for a large part, we've made some changes, but you often have to do that. There's often a compromise. Like, you know, let's say that's a good example. Oh, okay. You call a member function and there's a struct return. Is the this pointer push first or the hidden pointer for the struct return push first? You know, and Windows and Itanium ABI have different opinions on that. So in this case, we followed the Windows ABI because, well, we have to be able to talk to classes implemented, interfaces implemented in Windows, the OS. So, you know, if I'm going to call some method of iDispatch or IAmNone or iWhatever, and that method returns a structure, I need to be able to pass the this pointer and the hidden sret pointer correctly. So we're not fully Itanium ABI to as much as possible, but then we have to follow the Windows ABI because we have to interact with the OS.
Of course, yes. Well, we're starting to get a couple of questions, and here's one that I think is kind of interesting. David asks, not David I, another David, asks, since Clang is not that far along on Windows, in fact, and this is my interjection, this is the first commercial compiler for Windows based on Clang. The question, though, is do you plan to donate our extensions? What are our extensions, basically? And I'd like to just preempt that by saying, you know, that is important to support the upstream version of Clang, but go ahead.
Some of our extensions are already up there. I mean, I mentioned the -f Borland extensions. Just recently, we were looking at some things about SCH, and we had contributed that.
SCH is structured exception handling.
Yeah, structured exception handling. One of the issues is that we settled on version 3.1. I mean, we had to lock down on a particular version.
We have to actually ship a production-ready.
Yeah, so Clang is almost at version 3.2. I believe they've already locked down, and I saw the post yesterday that release candidate 3 was available. I don't know whether 3.2 has totally shipped, but that's where they are, and if it hasn't, it will be available in a few days. But the Clang team takes patches to the trunk, which is correct. I understand that. So we need to do a major, first of all, we need to rebase, and then we need to collect our changes and send it upstream. It was really difficult for us to get our changes correct and send it upstream at the same time while working on what we needed to do. So since 3.1 was settled, was locked down, we just kind of hunkered down and just said, we'll focus on 3.1, and then later we will push our changes. I would like to push as many changes as possible because otherwise it just makes it very, very difficult for us to move along with the compiler. with newer versions. Like, we want to go to 3.2, we want to go to 3.3. There are cool things in those versions of the compiler that I'm looking forward to working with that I'm sure our customers would love because, we can talk about those later. But so the idea of, yes, and we can't afford to lose our changes, so we do plan to push them, but the Clang team is also very selective, which is good about the changes that they take. So in general, things that apply to a wide array of compilers or wide array of code, I should say. Just a few days ago, someone pushed a patch for Microsoft property. Mm-hmm. And it was very interesting to see the interaction with the Clang team. And so we will have to see how our changes are received. And, and it'll be good for us to get that code reviewed to make sure that we did do it the correct way. So
wonderful. And the same David who asked the question had a comment, which he puts a big emphatic all caps yes. Thank you to the team for delivering this, and they're really looking forward to working with it and working with this architecture. As a follow-on question, he also asked, does the Delphi compiler use Clang too, or are they going to share the toolchain? You can go ahead and answer that one.
No, the Delphi compiler would not use Clang. Clang is limited to C, C++, and Objective-C.
By the way, Clang stands for C language.
Yeah, Clang would not. So the Delphi compiler could use LLVM as the backend. There's no plans to do that. There are no plans to do that right now because the backend that Delphi has works very well for Delphi. But should Delphi ever move to some other architecture, LLVM might be a considered candidate for backend support, I imagine. So it's all being talked about. So.
Actually, we have talked about publicly, actually, that the Delphi front end is using LLVM for ARM and iOS.
You mean the backend? I'm
sorry, backend, yes.
Okay, good.
So that is an important point, that they will share a common architecture in sharing the same IR stream as well as the LLVM backend to generate the code. So again, I welcome more questions from the audience. I see a few more coming in. We'll try to interject those as we go along. But I'd like to ask you, Bruno, moving from 32-bit to 64-bit. I remember back in the days when we had 16-bit DOS and even Windows, and there was a 20-bit version for a little while there, which was painful to work with. And then moving to 32-bit required some changes to code and some new ways to think about how you write code. What are some of these things that developers would need to think about as they move their C++ code from 32-bit to 64-bit?
Yeah, okay. Well, we've been doing a lot of that here, of course, because that was one of when we had to test our changes, and there's lots of information online about porting just Win32 to Win64 in general, or just X32 to X64 in general. I just put some data here. I'm going to try to pick a few common errors that you're going to run into. The basis of what I'm going to talk about is focused on writing code that works with both Win32, that is BCC32, and Win64, BCC64. Of course, some of you might want to take advantage of the new features of BCC64, such as all the C++11 and so forth. So I won't be talking about these. So that's the glitzy, the new things. I know there's plenty of talk going on about that. So I will just talk about the things that you need to do to make the code work with both platforms. And of course, you can always if-def. I won't show any code that if-defs because, of course, if-def is basic. I mean, if you want if-def, then yes, then you can go ahead and use lambdas and auto and all the good things. But I'll focus on things that you don't have to if-def. So the first thing, I just put a slide here about generic Win64 porting issues. Size of pointer doesn't equal size of int. Watch out for Win32 is always defined, so check for Win64. Watch when you're bit shifting. I mean, those are I just picked 3 of the top things that I see a lot in code. But there are long list of things available online from either Microsoft or from various websites where you can just search for, porting Win32 code to Win64. So I won't focus on that. The first thing that I'll talk about is our extensions, because BCC32 had lots of extensions, and you want to be aware which ones are supported in BCC64 and which ones are not. And the ones which are not supported are really supported, but we just don't support all the flavors of them. For example, the keyword underbar export and underbar import and underbar thread, we decided not to bring those over because there was already a way to do those with decal spec, and that's kind of the standard way of doing them. So if you had code that did underbar export, underbar import, or underbar thread, you'll want to change it to use decal spec. Both will run correctly. I listed the attributes. Those are the ones within the two square brackets, like final and no return and deprecated. These we did not add to BCC64 because the Clang team is talking about a very generic way of handling attributes. So we want to wait for them to do that. If you really, really want to tag something as deprecated or as final and so forth, you can use the underbar attribute, underbar format. So Clang has a different way of adding attributes. So then you would have to if-def. I'm just mentioning that here. For our own code, we're using a macro right now, and the macro expands to these attributes in 32-bit and expands to nothing in 64-bit. We also had some extensions with single underscore, like Pascal and cdecal. We did not bring those over. They're not really standard, and so you want to use either the double underscore keywords or the decal spec. ASM blocks. If you use ASM blocks, you'll get a nice warning that tells you we're ignoring it. So
well, the 32-bit ASM code wouldn't work anyway.
Yeah,
right?
yeah, but people might want to say, oh, I wish I could use RAX instead of EAX or something like that, and still use, I don't know, whatever move. And so in that case, you can either use a standalone assembler. Be careful when you do that because especially with exception handling and PData. So I recommend not doing that unless you're doing very, very simple things, leaf node functions or things that just jump. If the code you've written is going to be on the stack, on a call frame, and an exception is going to unwind, you probably don't want to use inline standalone assembler. You're better off rewriting the routine in C++ or C, and then let Clang and the optimizer and do the magic. I mean, I'm assuming the reason you were doing assembly was because probably you needed some performance. There are also lots of built-ins and intrinsics in Clang. I will provide more information about those later. I put a link here. Pseudo register is another extension that you won't be able to use, underbar EAX or underbar EDI and so forth.
Real quick though, on the assembler, that's a good point to bring up. Should people even write assembler anymore when you have such great optimizers on the back end? Well, I mean, unless there's a specific reason to talk to hardware or something like that.
Yeah, the optimizer is not the only reason. I would say that's one good reason, and it's a reason that people have used a lot. But what worries me the most is actually the PData information, which is the way exception handling works. So if we're in C mode, yes, go ahead. And we do ourselves. I've shown here some. We use NASM, -F, ELF64, and then your little ASM file, and we have quite a bit. Lee probably can touch on that. He has way more assembly than I do, but I have a few bit of assembly in that little layer that I talked about earlier, the EMU VCL. Very simple things. But in general, probably no. I mean, play with the online LLVM demo and look at the assembly code generated. I mean, don't get me wrong. Handwritten assembler can beat a lot of that, but is it worth the effort? I don't know.
Well, let me ask you, there's a couple questions that came in about this topic specifically. One is, can this compiler architecture output LLVM bit code or LLVM assembler instructions?
Yes. Emit LLVM. We do that all the time. Mm-hmm. Matter of fact, when it used to be back in the old days when BCC32 had code gen issues, I used to say, generate the assembly, -S.
Right.
When I started with BCC64, I did use a lot of -S. And then over time, I've learned to use LVMIR because lots of it can be found right at that level, and it's still higher level. So then you can understand where the issue was. I mean, it nicely separates real code gen in the back end from whether we messed up the tree or that kind of thing. So
very nice.
I use .ll files a lot. Yes.
And thank you, Robert, for that question. And back out to the audience, definitely keep them coming in. We're going to focus this session really still around largely moving to 64-bit. We do have two other sessions today we'll get into compiler architecture, and with Eli, as well as we'll talk about libraries. And we can, in all three of these sessions, anything's up, or we're going to have everybody participate. Yeah. So don't worry about us missing a question here. But the focus of this particular session really is mostly around 64-bit, moving to 64-bit. So let's continue on that way, and we'll bring some of these questions back in some later sessions where they are more appropriate.
There is a lot of overlap between, the compiler, the extensions, and the libraries. I mean, you need all three to actually do it correctly. So here I'm going to pick on a few errors that come up a lot. These are actually samples taken directly from our beta tester forum. So some of you guys, if you're online and you're also a beta tester, you probably will recognize those. Typically, they point out to areas where BCC32 was not as strict and did not enforce a particular requirement. And then now you move to BCC64 and you get an error. Sometimes the error is very, very simple, like this one. It says missing type name prior to dependent type name. That's very simple. You just put the keyword type name in front. I mean, the rule is that qualified dependent type names must be preceded by type name. So that's an easy one. But I just put it there because I want people to get a sense of the flavor of errors that you're going to run into. Accessing base members. Here's another example. This is also taken from an example that was posted. Here, the code has a grid as derived from tstring grid, and they want to access the in-place editor. And BCC32 would allow you to say return tstring grid : in-place editor. Well, that's not correct. If you want to access the protected member in the base, you have to use the current class name. So you should say use tmigrid : in-place editor. BCC32 would let you get away with it, but Clang will not, and it will basically tell you this is a protected member. I mean, if you're not scoping correctly. Two-phase name lookup. This one comes up a lot. We had a nice thread on the beta tester forum about this one. It's one that takes a little bit of getting used to because it seems like totally wrong that the compiler just would not let you access a member of the base template from the derived template. This is just an example. But there are good reasons for that, and I don't want to go into all of them. I've put links to all kinds of articles that people can read about here. And I remember like clearly on the forum where the tone was, oh, that's wrong, the compiler's wrong, and then slowly the tone changing, like, oh, okay, I now I see. I'm here just to, I assess a problem and I say whether it's a problem in Clang or whether we did something wrong or whether it's the spec. I'm not there really to justify, but this one will come up a lot, especially if you do a lot of template code. I had to change a lot of code. Diff sysset from XE2 to XE3, for example, to see a good example of where we've missed two-phase name lookup correctly. There are lots of other things. Let's say you're linking to libraries and objects. For an external objects, you can either add the object or the library to your project, but that's not a good way to do it if your code is going to work in both Win32 and Win64. The better way is to do panpragma link for an object or panpragma comment lib for library. That way, you can either, if def the code, or better, if it happens to be the same object or the same library, just drop the extensions. The thing to keep in mind is in Win32 we use .obj, and Win64 we use .o.
Right. And
for libraries, in Win32 we use .lib, and Win64 we use .a. So if you just say panpragma link test, you don't say the extension, it will automatically look for test.obj or test.o. Mm-hmm. And the same thing, panpragma comment lib, my cool library, it will automatically look for .lib in Win32 and .a in Win64. So that's the way to go.
So let me ask you a quick question. So these are definitely very specific C++ issues with moving from Win32 to Win64. And the Delphi crowd had gone through that conversion recently. Are there some more general rules as well about that, like pointer size, for example?
Yeah, that was on the first page. I kind of glossed over that. Yeah, that's true. Actually, reading even the Delphi page, which has a great page, talks about more specifics about what I didn't even go in details, like when you're shifting constant, make sure the constant is a wide constant, like don't shift one, because it's probably a 32-bit value, and then you're going to, you can imagine what happens in all those things. So a lot of the things that are mentioned on the Delphi page, or on any page for that matter, you even read Microsoft has great documentations about moving from 32-bit to 64-bit. All of it applies because they're talking about, messages, wparam, lparam. They're talking about set window long, get window long, and get window long pointer, and the macros. They're talking about, all these things apply. It's just I am picking a few things that are more related to our extensions or our specifics of what BCC32 allowed you to do, and BCC64 will.
So there are definitely some good resources out there.
Oh, there are lots of great resources. So
that are applicable across the board.
Yeah, in general, anything that says, here are some tips to move your code from Win32 to Win64 is probably a good read. I mean, validate everything they say, but all the information will be applicable. It's just there's no time you can go through all of that. So I've just kind of skipped through some things. I am actually not showing all the typical errors that you get into. I could actually show one of the things that I did this morning is I just compared the samples that we shipped in XE2 to the samples that we shipped in XE3 because we had to update our own samples to make them Win64 aware. And it revealed a few things. And actually, I kept a couple of. Let me just bring up some examples so that people can see like the kind of things that we did that would. So here's an example of. I hope this comes up. Comparing. Maybe I'm no longer connected to the network. I was going to compare the ribbon example to show. Oh, okay, it just came up. So here's the example of from the ribbon. We used to say grid panel color equals a constant here, and now it's rewritten to grid panel equals a constant cast to a T color. The reason is, well, T color is an enum, and with C++11 that has nothing to do actually with Clang, of course, is a stricter compiler, but C++11 on top of it is actually more strict also about enums. Where there's this whole concept of safe enums and so forth. So you can't just take a constant, like 0x4444, whatever it is there, and assign it to something that's you have to do casting. There are some other examples that I could show. So comparing even the code from, let me see, like the demo label is another good example. Comparing the code.
Real quick, is this code that also will work in 32-bit then?
Yes. Now,
these are good ways to write common code between both toolchains.
Yeah, everything I'm focusing on is actually writing the code so that it works for both 32-bit and 64-bit. I'm not showing any if-def code. So here's another example. If you look at XE2, this is not C++11. This is BCC32 allowing you to do something you shouldn't have been allowed to do. So we're casting a rect, which is a T-rect to a rect, and then we take the address of it. The cast returns a temporary. You should not be able to take the address of a temporary, okay? So here the code has been rewritten to do a reinterpret cast instead. So you can tell most of the, if I bring up a lot of those samples, the differences, there's very, very few lines that change. If you look at the number of changes, like four changes here, 2 changes in this. I'm just showing the comparison between. So we didn't have to change a lot of code to move from 32-bit to 64-bit, but we did. And I was just kind of skimming through the samples this morning just from a tree, just to kind of get an idea of the kind of changes we had to do. Some I didn't put in the slides per se, but it's very representative of the kind of things that you have to change.
Were a lot of these things, were you given hints by the BCC64 compiler, or were these things that you just more needed?
No, you're given hints, like I showed here, just this is not necessarily a good hint, the use of undeclared identifier fbase, but this is it tells you this is protected member, or this one says, missing type name prior to dependent name. So one of the cool things about BCC64 and /Clang are the great error messages. Well, I'll get to that.
I actually ran into that myself the other day. I was, I'm playing with the new language features and playing with Lambda expressions, and it gave me a beautiful error that told me exactly what I was missing. So that was, great help.
No, I can't take any credit for that, unfortunately. So.
Wonderful. So let me check. There's a couple more questions that I think are kind of interesting that just came in. By the way, thank you, Stephen, for that question. Let's see. So there's been questions about BCC32 and managing code between them. So that's what we're getting into now, is kind of ways to modify your code, not only to be safe in 64-bit, but that also make it compatible with 32-bit, so that it'll work in both situations. You won't have to if-def code to manage the differences between those.
I have yet to run into a case where the code was not, let's say, properly written up to the standard by BCC, and then when you update the code to make it up to the standard, BCC still accepts it. Mm-hmm. So I have yet to run into a case where when you write the code correctly, BCC refuses it. I meant BCC 32.
Correct. Yeah.
So you can always write the code where BCC 32 allows you to get away with something that's not right. But then you fix it. Let's say you put the keyword type name, or you do two-phase lookup correctly, or you cast properly, or whatever it is that you need to do. BCC 32 will still accept the code, and then BCC 64 will be happy with it. So then there is a way to write the code. And actually, I've noticed that people who wrote code and then compiled it with other compilers, any other compiler, GCC, MSVC, probably have run into that kind of thing. Every compiler has a little quirks about what things they let you get away with and what things they don't let you get away with. Mm-hmm. So it comes a point after you put your code through enough compilers, the code pretty much flies nicely now. Mm-hmm. So for people who've stayed only with BCC32 the whole time, you will discover a few things. But the general reaction I've seen on the forum has been, hey, I'm loving this because my code is now more compliant.
Exactly.
It's a little frustrating when you don't understand why the compiler is not happy with it.
The two-phase
a two-phase name lookup. Yeah, I know that one has been a little complicated. But once it's understood, in general, the reaction has been, I love it. My code is more portable. Now it will compile easier with VC or with GCC or with EDG or what have you. I mean, it's a good thing to we have benefited internally by putting our code through BCC64 and BCC32.
Right, and like you pointed out, we've gone through this conversion ourselves with our samples, with our libraries that we support as well. In BCC64.
And we're still, I want to point out, we are still building big code bases with that, okay? So Boost was a big experience for us because samples are relatively simple. I mean, the samples are, they're more glitzy than anything else, Boost. And we plan on building, I'm still working on Owl next. It's been great to have that library. That was a library I used to work on in the early days, in the 90s. And it's been pushing our tool chain, because of the size and so forth. And we're working on that. So we do plan on grabbing as much source code as we can and putting it through spaces and validating that we haven't missed anything somewhere, and tests and so forth. So it's an ongoing process.
Right. And with that said, new architecture delivery. So as you folks starting to use this tool chain out there, certainly make us aware of any issues you may be facing, especially if you're going from 32-bit to 64-bit. Those things we definitely want to be made aware of as soon as we can, and we intend to release updates to address any issues we find out there in the field. So the question, I've seen this a few times now from a few people, but they're asking about 32-bit version of Clang LLVM, and I'd like to take a moment. I did talk about this during the product address. So this new architecture is a very important for us and for our future. And 64-bit Windows is the first platform that we're targeting with it. We intend to take this architecture forward for any new platforms that we support. And right now, our priorities are to get onto iOS and Android with this architecture, and this includes the Delphi side as well. So that's where our priority is. With that said, our intention is to, and I use the term backport, but bring this support back to 32-bit eventually. And though, unfortunately, I don't have timing to share with that, that is something that we are definitely planning to do in the future. So just one question that maybe it's too early to answer, but are we going to use .a.lib in that version of the compiler? I imagine that it would be yes, but I don't know.
You mean like if we were to go to Win32?
Yes.
Yeah, I mean, we use .o and .a mostly because it's customary for ELF files and, I mean, the tool chain and so forth. there's no reason. I mean, whether we use .obj or .lib, it's, I mean, we were mostly conveying the format that we're using there. I mean, the images we produce, of course, are PE images, PE plus images on Windows, but the library themselves are ELF files, ELF objects, so that's why we chose .o and .a. There's absolutely no reason why we couldn't use .lib. It's just that they won't be COF files, you know.
Right, and we don't want to confuse people that.
Yeah, exactly.
Right.
Exactly.
Well, and thank you for the question, Ben. And David also had asked about that. So again, any other questions out there, definitely feel free to bring them up. Again, the focus of this session is really around 64-bit, and we do have additional sessions later today around compiler architecture as well as libraries overall. So Bruno, you covered quite a few of these already, but any other recommendations around managing 32-bit and 64-bit versions of the same application with the same code base so you don't have to if-def?
I have a slide here, packages and components. One of the things that we didn't do is we did not add the support to produce packages in the RTM version. That's something that we will be working on later. So if you're using components that were written in C++, let's say TCPP web browser or TPy and so forth, what you'll want to do is link statically. I know that that's not necessarily the preferred approach of everybody, and I understand that that's a problem in some cases, but you'd want to do that. Also, when you are using the IDE, and the IDE is generating events, there's a little bit of something that when we interface with Delphi code, you kind of see behind the scene of what the Delphi compiler is doing. And so let me give an example. Let's say there's a record, and the record is, let's say, 8 bytes long. Let's take T-point, for example. In Win32, even though you're passing it by value, behind the scene, Delphi is passing it by reference, because 8 bytes do not fit in a register on Win32. So it's more efficient to just pass the pointer.
Mm-hmm.
But then in Win64, it does fit in a register. The register is 8 byte long. So now, unfortunately, C++ gets to see that ugliness behind the scenes. So now your event handler, if it were to receive a T-point, has 2 different signatures. So now when you're in the IDE and you go to your object inspector, you pick the event, you double click on it, the IDE gives you a nice signature. That signature doesn't work for Win64, it only works for Win32. So we have to be a little aware. The team has ideas about how to solve this problem. We don't want the finer details of what the Delphi compiler is doing behind the scene to seep through the interface.
Mm-hmm.
With BCC32, that was really we had to do it this way. With Clang, we don't. And there are nice ways with Clang to address this issue. But that's not addressed right now because we're still living in a world where your code might need to work with BC32 and BC64. So be cognizant of the case when you're writing event handlers in the IDE, watch for the signature. And so that's a case where you might either want to let the IDE generate the event handler and then do the 64-bit slightly differently, like with a different event handler, or just not use the designer to generate the event handler. Write that one by code and hook up the event programmatically. It's unfortunate, and it's something we would address. Another area that's not covered, I don't have a slide for that, but it's just making me think of that. Let's say you have Pascal code in your project, which is very common.
Yep.
So you might have found this great unit online that you want to use, and we allow that. You put a Pascal file, a pass file in your project, your C++ code can call every interface in there. DCC32 will generate one HPP for that pass file, and DCC64 will generate different HPP for that pass file. Depending on how the pass file is written, what the interface is, maybe the header will be identical, in which case it doesn't matter which HPP you include. But sometimes, depending on what you wrote, the HPP might be different. So you want to be aware of that so that your 32-bit version is including the 32-bit HPP and the 64-bit version is included the 64-bit version of the HPP.
Mm-hmm.
We solve that problem we generate both sets of headers and then we merge them using just standard diff. We merge them and then whatever differences is if-def with if-def and above Win64. So that's something you can do also as a customer, as a user of the IDE. Or you can do as some of our third-party vendors do, you just keep the headers in separate directories and then use different include paths. So that's one thing to keep in mind. All that, the goal there is to write one code base that works in Win64 and Win32.
Right.
So if you have pass files, that's another thing to be aware.
So when dealing with situations where you may need to if-def, is it best to look for underbar 164
Yes.
or look for some other? Okay.
No, you look for underbar Win64. We tend to if-def based on underbar Win64 if it's really related to Win64, and then we if-def on underbar Clang, underbar if it's something that's a language issue.
Right.
Like, so if you look in our headers,
like using the new auto keyword, for example.
Yeah, something like that. Or let's say if we do something that has to do with enums, strictness of enums with C++11, or const expression, const expr. And so those we will then if-def with Clang as opposed to Win64, right. Because if we go to another platform where we're using Clang, we want those changes to come along. So
understood, okay.
You have to kind of use it. For now, underbar Win64 and underbar Clang are kind of equivalent, but when and if we go to other platforms, then, underbar Win64 will go away, but underbar Clang, underbar will still be around. So
speaking of that, how did using Clang make it easier to interop with Delphi code? Or did it?
Oh yes. Using Clang made it so much easier to interop with Delphi code. I'll share a couple of instances. We had gone along and we were building some samples. I mean, one thing that we did, we asked the QA team to go and download all the samples that were posted on Code Central, C++ samples, and then just build those under Win64 and tell us what they run into. Now, of course, if the code was written in a way that's too specific to Win32, that's fine. But I ran into this sample that somebody sent me, Pong, that had used a black background, and the phone would not load, and it said CL black is an unknown color. And I thought, interesting. It turns out that Clang was generating type info for T-color that was conflicting with the Delphi type info for T-color. I can't go into the details, but I'll skip that. And what we needed is a way to tell Clang not to generate type info for T-color. And, back in the days of BC32, we would be scratching our heads thinking, where do we get another bit? We're out of bits. We can't add a flag. Oh, my God, what are we going to do? The whole world's going to fall apart. With Clang, I just talked to my colleague over the wall. We said, hey, we're throwing an attribute in here, and, you'll use that and not generate type info,
Nice.
And before I was done sitting back on my chair, the feature was implemented, and it was running. We've had lots and lots of instances of that. I mean, it's just, Clang is so modular that it makes it very, very easy. I should probably say it's not just Clang. C++11 itself makes it much easier to interact with Delphi code. Right. Like C++11 has those type-safe enums. I mean, I'm picking on that feature, but let's say now you can tell whether an enum is based on a char, or on a short, or on an int, or whatever. We used to litter our HPP files with -b dash, pragma option -b dot -b, because the size of enums in Delphi and C++ were different. C++ defaults to size of enum, size of int. Delphi defaults to size of enum, the smallest size. And we used to just put all these things. And then when C++11 came along, I'm like, hey, we're going to make enums use the underlying type. I was so happy the day I turned off that emission of all that pragma options in all the HPPs. And now I never have anybody come to me and say, oh, the enum is the wrong size.
Right.
And so it's not just Clang, it's also C++11. There are other C++11 features which also will make it much, much easier to interact with Clang. I'll let other talks touch on, not with Clang, I meant with Delphi. So there are lots of features of either the new compiler or the new standard that make interoperating with Delphi much, much easier.
So and obviously we're targeting Windows here. What were some of the things about using Clang to target Windows? And this is the first commercial compiler to support Windows.
Okay, well, that's maybe a little sore point. Clang is not, is not running on Windows. I mean, at least not viably, and that caused some problems. For example, some of the things I can think of is Clang assumes your input source is UTF-8. Okay, I mean that's just kind of part of the pedigree, part of the background of the OSs that it runs on, and that one is easy. Okay, you either make the user save their files in UTF-8. I mean, if they are using non-ANSI characters. But the worst part is Clang also stores what we call the execution character set. So like the stream of bytes that will go down when you have a char array stores it in UTF-8. So let's say you say you declare a char, and let's say you assign it the euro symbol. which is hex 80, you know, in our code page 1252.
Right.
So this is one byte, the euro symbol, you know, one character. Clang will store it as UTF-8, which turns it into 3 characters. Or it will give you an error, tell you, oh, I can store this into a char. That, again, has to do with its pedigree, with the background of Clang, which is more OSX based, where, you know, char there, char star is assumed to be UTF-8, you know. And so that has caused some problems for us. And, I mean, and nothing that's insurmountable, but so there are some areas like that where we had to do some tweaking around to get Clang to be a little more, like every Windows compiler pretty much assumes the NC code page as far as the source code and as the execution character set. So that's an area where the Windowism did not sit too well, but you know, it was easy to work around, but this just goes to show a little bit of like the fact that the compiler is not really in the Windows world as much as it is in other OSs.
I think also partly evidenced by the file extensions that we've selected to use and the formats. Speaking of that, a question has come in from the audience. And by the way, we're at the top of the hour. We'll probably just go about another 10 minutes, and then we'll pick up the conversation at noon, because there's a couple of compiler-specific questions that have come up also. But one of the questions is, how do I convert an existing lib to the .a format? I don't think there's a way to convert that. You'd have to rebuild that code, right?
Yeah, I mean, you have to recompile the code. You could either use DCC64 if it was a Delphi code, or use BCC64 if it was a C++ C code. Yeah.
Or if you're very familiar with the hex editor. Just kidding. You don't want to go there.
No.
Another question, and thank you, Tomas, for that question. Ben has a question. Do the HPP files generated from the pass files for 64-bit, do they include any C++11 features?
No, we don't. We don't use any C++11 features. Let me think about that. No, they use set, of course. Some of the libraries that they use, like what I mean by that is that EMU VCL layer, that layer that emulates Delphi built-in types. Do use C++11 features. Well, I take that back. Actually, we use scope enumerations in the HPPs, and we do use, so that's one C++11 feature. I don't think of it so much as new because BCC32 also had some C++11 feature, including scoped enumeration.
Or your favorite type-safe enum.
Yeah, type-safe enum. So yes, we do use some C++11 feature, but nothing like auto or lambda or something like that. Right. So anyway.
Okay, well, you know what? I think what we'll do here is we'll go ahead and wrap up this session.
Okay.
Like I'd like to mention again, we do have follow-up sessions with primarily Eli at noon and primarily Lee at 1, but we're going to have all three participate. Bruno will be back, so we'll continue. We can continue on with these conversations. So any questions around this topic are welcome. And we'll be happy to answer those. Anything to close with for this session, Bruno?
Well, I'd like to leave my contact info, so I just switched the slide to that. I want anybody who's using the product to be able to contact us. I mean, we do have QCs and tech support and so forth. I want the formal channels used, but I also want people to be able to contact us directly because, I mean, this is, let's face it, a 1.0 product as far as our implementation of Clang. And so if there are any issues like that, or, I just want people to be able to just fire me an email and let me know what's happening. And then at the same time, follow QC, go on the forum and the news group and so forth. I monitor those, but
maybe we should put your mobile number on there.
Okay.
Just kidding.
I just wanted to make that available. And also, I'll make the slides available. There are a few things here that I didn't touch on, but that people might find interesting. So some of the cooler things about BCC64 that, like binary constants or printf validation. This is a feature that people have asked for a long time.
I think this would be something that we could talk about during the compiler architecture session. So save those, and we'll definitely get back to those.
Okay.
All right, wonderful. Thank you for your time, and again, congratulations to the team on this release. And we will be back for live Q&A with the C++ R&D team at 12 noon Pacific. Thanks again.
Thank you very much.